for such a kind introduction, and I'm very delighted to participate in this FDP, which is on Internet of Things. And today I'll be talking on one of the recent topics which has gained our attention from research point of view as well as from learning point of view, which is on Internet of Medical Things. I thank Dr. Shyam Sundar Agrawal, Surendra Kumar Agrawal, Sanjeev Yadav, all my friends are here, Deepak Jhamarji. Now I'll start sharing my presentation.
Yes, sir. Thank you very much, sir.
So is my screen visible to you?
Yes, sir, it is visible and you are well audible.
Thank you so much. So I'll be talking about Internet of Medical Things, and nowadays we have seen that in past couple of years, a lot of attention people are paying on their medical fitness and their physical activities, and they are also paying a lot of attention on their health. They are exploring all kind of possible gadgets and treatments and preventions that they can take to keep themselves fit and healthy. So with this, I start my presentation on Internet of Medical Things, which basically deals with the interconnected medical devices which can be used for monitoring and also for treatment of an individual. So providing healthcare is nowadays becoming more and more challenging. Global healthcare spending expected to grow from 7.1 trillion in 2015 to 8.7 trillion by 2020. So there is a tremendous growth in global healthcare, which is being foreseen in last 5-6 years. And the people who are aged 65 and over is expected to double by 2050. So this is actually going to demand a lot of healthcare attention to such people. Death of non-communicable diseases are anticipated to increase from 38 million in 2017 to 44 million in 2030. So this year we have already seen the spread of pandemic in form of COVID-19, and in addition to this, non-communicable diseases are also anticipated to increase in coming maybe a decade or so. So to reduce the spending and improve outcomes, healthcare organizations are looking for medical technology companies to demonstrate the value of their product. And here is where the Internet of Medical Things comes in picture. People's interaction with healthcare system often involves interaction with wide range of products that diagnose, monitor, or treat patients. So basically, these devices and equipments are instrumental in helping healthcare providers to achieve better patient outcomes, low healthcare costs, and improve efficiencies and enable new ways of engaging and empowering patients. So nowadays we have seen that people are paying a lot of attention, and so the market players are also paying attention to this side, so that the overall health care system is improved and people are benefited from this improved healthcare system. I remember around 2 months back, I was participating in one of the workshop which was related to innovations, and in that workshop there were more than 20 ideas that were pitched to actually become a product. So I remember that out of those more than 20 ideas, at least 50% of those ideas were related in some way or other related to health and life risks. So nowadays people are paying a lot of attention to this side, and that's why Internet of Things and Internet of Medical Things and IoT in healthcare is gaining so much importance nowadays. So let us have a look at what is Internet of Medical Things. The healthcare industry has become more open to latest technologies and IT services platforms, bringing drastic changes in the industry. We remember that earlier there were healthcare systems and that were mainly used for diagnosis with physicians. They were all non-electronic system, and even we remember, even we know that nowadays also some people who do conventional type of treatment, they rely mostly on the old type of systems which are non-electronic for measurement of blood pressure and temperature and all those things. So they say that this one is better than what we have nowadays. But believe me, the sensors and all these things have the technology has become so sophisticated nowadays that we see that the precision of the electronic instrument is far better in comparison to what we used to have maybe 20-30 years back. So recent studies and statistics show that technological advancements are transforming the industry. Along with opportunities, certain concerns also arise. We are going to look at those concerns also in this presentation. So basically, the type of IoT systems that we see very common is wearable and tracking device like Fitbit and Reflex by Fast Track, and there are many other by different players for tracking the different activities and different kind of physical parameters. So these tracking and wearable devices have become part of everyday healthcare processes, intervened with an evolving healthcare delivery model. According to studies, wearable technology market is set to rise from $20 billion in 2015 to 70 billion in 2025. So it is almost going to become 3.5 times in just 10 years. Then there comes patient-centered care, which focuses on individual healthcare needs, is found to eliminate and reduce unnecessary and costly treatment plans, which need referrals to specialists. So this is also one major area which comes under IoT. Third is the concern which is there associated with the advancement of technology. The concern is of data security, because this is the concern which everyone has when dealing with huge amount of data. Payers and providers are finding ways to increase data security and avoid violations of different kind of acts that are available at different places. The data demands have also increased, and this is also a driving factor for healthcare industry. 1 million GB is expected amount of healthcare data generated by an individual in his or her lifetime. Just imagine 1 million GB. With such huge amount of data available for determining every healthcare aspect of a system, from surgery plans to diet control, data needs to be warehoused and analyzed for getting the right healthcare approach. So let us first of all try to understand what is IoT. The Internet of Medical Things refers to the connected system of medical devices and applications that collect data that is then provided to healthcare IT systems through online computer networks. Now we all know that there are a lot of gadgets, wearable gadgets that we already have at our home, and we are wearing them and using them almost every day and every time. And there are certain apps also that are available on your mobile, and I believe that everybody has them. Like one of the most common and most popular app is Google Fit, which tracks your activities, different types of activities, and your physical parameters based on what input you give, and then it keeps track of them as and when you change them. So these things are becoming more and more popular, and when they get connected to a healthcare IT system, so that this collected data can be utilized for diagnosing or for treatment or for monitoring, then it becomes an Internet of Medical Things. Otherwise, you can use them disconnected from rest of the system. It will be working as a standalone system, which you can utilize for your own monitoring of physical parameters. So the IoT can help monitor, inform, and notify not only caregivers, but provide healthcare providers with actual data to identify issues before they become critical or to allow earlier intervention. So the objective here is to kind of preventive maintenance, that the body parameters are continuously monitored, and before it becomes critical, a proper care can be given to an individual. So this is something which IUMT can play a tremendous role in healthcare industry. So in this IUMT system, the scope is basically, we know that IUMT is coming from Internet of Things. So when these things are related to medical science, then it becomes Internet of Medical Things. So this IoT ecosystem has a very complex architecture in which multiple components interact with each other to enable various solutions for the end user. It is an interdependent system which enables real-time data acquisition, device connectivity, data transfers, and analytics to control end user applications. IoT provides the connected environment comprising of cyber physical systems which integrates human intervention with computer-based systems and facilitates data-driven decision processes. And IoT encompasses technologies such as smart grids, smart homes, intelligent logistics, smart towns augmented with sensors, actuators, communication, protocol networks, and it provides real-time solution through integration of data analytics and sensors embedded in machine. So these are certain characteristics and features of an Internet of Things. Now, when, as I just said in the opening of this slide, that when these things are related to healthcare or medical science, then it becomes Internet of Medical Things. So the healthcare industry stands as the third most advanced industry in IoT implementation. So it is already third most advanced industry in IoT implementation, with 60% of healthcare organizations having introduced IoT already in their patient care activities. 87% of healthcare organizations across the globe plan to implement IoT related services by 2019. So it must have already done. Actually, this data has been taken around 2 years back, before 2019. So it was 2017 data basically, making IUMT as one of the most sought after technological platforms in next 2 years. Despite the concern and possible issues, IUMT has helped in increasing workforce productivity and has reduced Medicare costs considerably for individual as well as for healthcare companies. 73% of organizations utilize IoT for patient monitoring according to studies. So mostly it is being utilized for patient monitoring. Security of sensitive medical data is a big concern. 89% of healthcare IoT users have experienced some kind of security breach. So let us now look at the various solution categories of IOMTs. So the categories can be clinical efficiency, where the efficiency of clinical devices or infrastructure may be improved by connecting them and monitoring the operation of these devices. Consumer or home monitoring is also one of the category. Fitness variables like Fitbit and other fitness bands is also one category of IOMT solutions. Infant monitoring. You might have noticed that nowadays there are a lot of camera systems and other systems which are already in place for domestic use for monitoring the infant. So more or less they can also be counted as an IOMT device. Otherwise, there are sensitive IOMT devices which can be used to monitor the condition of an infant, so that if there is some thing unusual which is noticed, it can be immediately taken care. Then there are biometric sensors and wearables, brain sensors, neurotechnology, is another category of IoMT solutions, and sleep monitor is also one of the category of IoMT solutions. We are going to just see each of these kind of categories in details in coming slides. So basically, clinical efficiency in this category, hospitals and dedicated clinics are using connected objects to improve the delivery of Medicare. They can track treatments and perform automated electronic charting. Doctors can track patient visits and access EMR even from remote locations. IoT sensors can be used for location tracking of patients and medical equipment in real time. IoT has been used to develop health portals that track medicine adherence. So these are some of the activities that come under clinical efficiency for improvement of the medical services. Then comes consumer and home monitoring. In this category, IoT technology is directly marketed to consumer for self-monitoring and collecting biometric information. Example, smart thermometer, which reads temperature using temperature sensors in smartphone or other devices. Nowadays, there are devices in the market that can get an ECG at home. Such devices help track and collect patient information right from their homes and also assist in telemedicine services. During this COVID-19 situation, we have already seen there are a lot of clinics and hospitals which are giving this telemedicine services and even teleconsultancy services. So all these activities are nowadays increasing, and so is the intervention of IoMT devices in day-to-day health monitoring. Then there are biometric sensors and variables. IoT can be implemented in connected biometric sensors.
There is no audio coming, I think.
Hello? Hello? Can you hear me?
Yes, sir. We are listening to you, but probably one of our participants is telling that he is not able to listen.
Okay.
So
Okay. So
I'm very
No audio, please.
So maybe the microphone, the speaker is off.
Srinivas.
Okay.
That is, sir, probably it is problem at your end because we all are listening.
Okay. So this IoT can be implemented in connected biometric sensors for use in a clinical.
Hello, there is no audio coming.
May I take opinion of other participants, please? Audio is coming or not? It is probably his own personal problem.
Audio is okay.
Audio is coming, sir.
Okay.
There is no problem.
Then it's only for me or what?
Hello.
Yeah, probably, sir.
Hello, Ganesh ji. Good morning.
I see.
Good morning, sir.
Okay, sorry. I will try to
Good morning,
relog in. Okay.
Right.
Good morning, sir.
Good morning. Good morning.
Thank you,
So-
everyone.
Thank you so much. Can I continue?
Yes, sir.
Okay. So next category is biometric sensors and wearables. IoT can be implemented in connected biometric sensors for use in a clinical and hospital setting. Heart patches that monitor heart-related readings, blood pressure reading armlets, etc., can even be connected to clinical monitoring devices situated at a different or a distant location. Recently, smartphone-enabled auto-refractor applications for vision testing are also available. Then there can be fitness wearables. This is one of the most common kind of IoMT devices that we are using. Fitness tracker or apparels or consumer wearables which can collect data and regulate the fitness regime of an individual are very much sought after in the market. Almost everybody is nowadays wearing a fitness device. These devices connected with smartphone enabled applications can track and give reports on the fitness of an individual. There are certain apps also which can be connected to these fitness wearables. These are third-party apps, and based upon the physical activities that one is doing, they suggest a diet chart according to the weight increasing or weight reduction targets of an individual. So there are a lot of things that are happening nowadays to improve the health of an individual or to monitor the health conditions of an individual, and people are nowadays becoming very cautious about it. So there can be brain sensor and neurotechnology category is also there. Researches are in progress to develop high-tech consumer-targeted cranial wearables, IoT devices capable of reading brain waves, track and transmit mood elevating, neurosignals, etc. can be used to help monitor the mental health of patients. Non-invasive neurotech brainwave reading or recording are also being researched on, which can be used for analyzing drug efficiency. In addition to this, another category is there for infant monitoring, wherein IoT-enabled wearables which monitor and transmit infant movements, temperature, and sleep patterns to the patient. Handheld device like smartphone is another application of this technology. It assists parents to constantly aware of their baby's physical condition and respond accordingly. Then next category is sleep monitors, where sleep tracking and monitoring has been a part of treating sleep disorders and other neuropsychological disorders for years. IoT-enabled devices can track and send continuous reports to clinicians situated at distant locations. The smartphones-enabled applications which can be connected to hardware sleep monitors can further help in regulating sleep patterns without clinical help. So now let us have a look at the IoT market. We have seen that it is nowadays gaining so much of importance, and people are becoming so much aware about these devices and their health. So let us look at where this IoT market is going. The IoT market is forecast to expand at CAGR of 37% to USD 156 billion by 2020. Technologies used in IoT can be divided into three technical classes. First, local patient systems and controls, including sensors, controllers, firmware, and medical devices. Second, device connectivity and data management comprise networking and database systems. And third one is analytical solutions, broadly consist of data analytics and cloud-enabled solutions and services. The major technology contributors in the IoT ecosystem layers are firms that provide semiconductor and embedded systems, application developers, firmware companies, wireless network operators, data management companies, sensors, telepresence, and location technology providers, internet security and privacy, and machine-to-machine vendors, IoT service providers, and general telecommunication players are mainly in this market for development of the infrastructure as well as technology in IoT ecosystem. So in the current scenario, North America leads the market in a high penetration of medical technology and government insurance policies. In future, analysts forecast growth of technology in Asia Pacific and European market due to increasing awareness, change in lifestyle, improved diagnostic facilities, and disease burden. So as we just discussed that 30.3% of IoT devices in the healthcare since its introduction in the industry. So this is the growth in the IoT devices. And if we look at the IoT in connected healthcare, then the global digital health market is estimated at $179.6 billion, expected CAGR of 13.4 from 2017 to 2025. It will reach $536.6 billion in next 7 years. So there is a considerable contribution of IoT in IoT growth, as well as IoT growth is also tremendous in last few years. So here we see that the status, drivers, and challenges of IoT market. So status, you can see that the graph, the bar graph, which is there on the top, in last 5 years, there is an exponential growth in the IoT market. the government policies, lifestyle changes, patient engagement, competitive offering, shorter lead times, increased awareness, aging population, and device availability are the main drivers of this IoT market, where challenges are security, data complexity, interoperability, and connectivity problems are the challenges in this market. So now let us look at the adoption of IoT in healthcare. Already, nearly 60% of healthcare organizations have introduced IoT devices. 73% of healthcare organizations use IoT for maintenance and monitoring. 87% of healthcare organizations plan to implement IoT technology by 2019, which is slightly higher than 85% of businesses across the various industries. And nearly 64% use IoT in the healthcare industry is patient monitors. So you can see that there is a lot of adoption already in healthcare for IoT's devices. So this graph, the bar graph, it shows the Internet of Medical Things by different categories divided as medical devices, system and software, technology, and services. So you see that nowadays medical devices have become they are one of the most popular in the market, and so is the market share of medical devices in IoT devices. Similarly, system and software, technology, and services are also increasing. As you can see that in past 5 years, they have increased a lot, and they are expected to increase year by year. And by 2022, it is going to become very large share in comparison to 2017. So again, the second picture shows that the growth of IoT devices is going to become almost 4 times in every part of this world. So currently, North America is going to become $45 billion in 2022. South America will be around $9 billion. Middle East and Africa will be again $9 billion. Whereas Asia Pacific, you can see that there is a tremendous growth which is expected in Asia Pacific region. Maybe because of the high population of this region, it is expected to grow from 11 billion in 2017 to $51 billion in 2022. So the future of IoT looks promising. Spending on healthcare IoT solutions will reach staggering $1 trillion by 2025, and hopefully will set the stage for highly personalized, accessible, and on-time healthcare services for everyone. In 2025, remote monitoring could create as much as $1.1 trillion a year in value by improving the health of patients with chronic diseases. Today, there are 3.7 million medical devices in use that are connected to and monitor various parts of the bodies to inform healthcare decisions. So the future of IoT is very promising, and it is expected to grow in coming years. So let us have now a look at the components of IoT on both patient as well as physician side. So at patient side, There are image digitizers that include main, auxiliary, and document camera or scanner. There can be devices like ECG, blood pressure measurement, and oxygen monitor. There can be user displays so that the patient himself can see the data on their mobile or computer screen. And then this digital data is converted in an electrical signal to transmit to physician for monitoring and possible treatment. Then there is a communication network which will enable this transfer of data from patient to physician. And on physician side, the components can be the display, which can be used for remote intervention and monitoring. The data can be received by using communication devices such as modems, and a camera can also be there on the physician side, which includes main, auxiliary, and document camera for capturing the images related to the treatment or monitoring. The impact that IoT is expected to make is in patient-specific care with context and enabled through past health records, development of evidence-based guidelines which can be helpful to incorporate the local intelligence in future machine, improved inter-device connection and synchronization, data-driven health prediction, and real-time tracking and intervention at the physician end. So the IoMT would help to diagnose patients, and this is going to be the biggest use and impact of IoMT to ensure adherence to doctor order. A connected medical device provides objective reporting of actual activity, whereas without it, reporting providers must rely on subjective patient reports to detail how they feel. There are some connected devices that allow internal surveillance in a way that's never been available before, especially with smart technologies added to medical devices such as pacemakers. The biggest impact of IoMT is prevention and predictive care, as it helps reduce the number of hospitalizations while improving the quality of care. As a result, resources can be allocated in the areas that have the most critical needs. So the impact of this IoMT is quite visible, and we see that people have already started using these IoMT devices as a preventive or predictive care equipment. The main advantages and limitations of IoMT devices from patient point of view is that real-time intervention. Hello.
हाँ? ऐसे मिलके तो नहीं आएगा आज. ऐसे मिलते नहीं आएगा आज.
I think somebody's microphone is
Yes,
on.
I have muted him, sir. You may please continue.
Okay. So from patient point of view, the benefits are that real-time intervention of emergency situation is possible. The cost is reduced, and reduced morbidity and financial burden due to less follow-up visits is there. From healthcare service provider point of view, optimal utilization of resources and infrastructure is possible due to this IoMT. Reduced response time in case of medical emergency is possible. From device manufacturer point of view, standardization and compatibility and uniformity of data is available. Capability to sense and communicate health-related information to remote location is possible. At the same time, there are some challenges and limitations that are existing, such as security of IoT data like hacking, unauthorized use of IoT, lack of standard and communication protocols, error in patient data handling, data integration, need of medical expertise, managing device diversity and interoperability, scale, data volume, and performance are some of the technical challenges. Market challenges are physician compliance, data overload on healthcare facility, mobile hesitation, and security policy compliances. So these are some of the advantages and limitations. Let us look at from a different perspective to these advantages and limitations. So the present day advantages of IoT devices is that improved treatment outcomes as a result of round-the-clock patient monitoring and care deliverance, decreased Medicare cost as a real-time and remote monitoring of patient is made possible, resulting in fewer clinic visits. So because of all this, the timely treatment is possible, as well as costs are reduced. Visible improvement in disease management as patients are given care by careful real-time monitoring. Enhanced patient experience as an individual gets complete and customized treatment and care. Improved drug management is another scenario that is possible as a growth of IoT growth. As a result of IoT growth, where devices and applications can assist in drug research, deliverance, and adherence. Some concerns and future necessities are new innovations in sensor technologies can drive IoT platform forward. There are a lot of research in sensor technology which is going on in our university also on IoT related devices, or maybe healthcare devices, as you can call it. Intelligent networks will be part of IoT in near future. Developing high-speed cloud computing platforms can definitely assist in the growth of IoT. Advanced analytics can help process large amount of data passing through IoT devices and use it as per need. Stronger security should be provided to these devices so that consumer data is protected around the clock. So security, as you can see, it is coming out to be one of the major challenges that or concerns that can be there related to IoT devices. There are a lot of applications also. So let us discuss these applications in details now for IoT devices. So existing medical devices can be modified into IoT devices to sense real-time data for patient monitoring through enhancements such as sensors, signal converters, and communication modems. IoT devices have been conceptualized in various forms of smart wearable devices, home use medical devices, point of care kits, and mobile healthcare applications, and are able to communicate with medical experts in remote location. Apart from their utility in managing regular health statuses, they also have been used for disease prevention, fitness promotion, and remote intervention in emergency situations. So nowadays we see that there are a lot of medical devices which are already available at almost all homes. Some of the most common devices are electronic glucometer is there. Now almost everybody, every home has an electronic glucometer. Then BP devices are also present at everybody's home nowadays, so that people can monitor their blood pressure. And with this outbreak of pandemic in recent times, nowadays oxygen meter is also, blood oxygen meter is also one of the most common devices. It has become one of the most common devices in all homes. Electronic thermometer was already there since last maybe 10 years or so. So there are a lot of medical devices which are already available. Now the need of conversion is there to convert these medical devices into IoT enabled devices, and this can be done by using of signal converters and communication modems. Now, some of the applications is chronic disease management. IoT-enabled devices offer promising alternatives to manage chronic morbid disease conditions such as hypertension, cardiac failure, and diabetes. As I just mentioned, that some of the medical devices are already present at all household. Such devices are used to monitor parameters such as blood pressure, random blood sugar levels, and weight and electrolyte concentration inside the body. The real-time vital data sourced by these devices is processed at a higher level and used for future treatment alterations or dose changes and to predict the disease progress. So the data which comes from these devices can be used to treat the alterations and suggest the dose changes to the patients. Furthermore, centralized data collection can be useful in studying the epidemiological trend in the particular disease in a specific population. Then there can be remote assisted living. This is also one of the most important application of IoT devices. The data from network devices is registered at a central location at the physician's office. Compiling and processing patient-specific data enables healthcare automation, which analyzes fresh data against past records and decides the future course to manage the patient. This machine-enabled intelligence helps service provider transfers the task of routing, monitoring, and field administration to IoT machines, thus saving the cost incurred from implementing follow-up resources and infrastructure utilization. Additionally, remote monitoring has led to decrease in member dropout rates and increase in healthcare resources productivity. One of such remote monitoring system is BodyGuardian, and it is one of the commercialized systems used for cardiac monitoring, which separates patients' identification information and observation data to ensure security. Furthermore, encryption protocols are used to transmit and store critical information, which ensures the reliability of the solution. Next application of IoT is wellness and preventive care. IoT-enabled devices have facilitated health supervision with monitoring systems for diet, physical activity, and quality of life. Recently, I came across one of the apps that is there on Google Play called as Healthify Me. So this Healthify Me can be integrated with some of the monitoring apps or devices so that the information related to physical activities can be transmitted to this app, and then this app analyzes the requirements of an individual for controlling of various body parameters such as weight and other body parameters. Innovative devices such as wearable devices, implanted chips, and embedded systems in biomedical devices track continuous data on patient activity and related vital changes. Advanced sensors, converters, and firmware in smart devices allow user to analyze and correlate various vital events with health conditions at the local level. Additionally, remote networking capacities of these devices provide expert assistance in emergency situation at any remote location. Remote intervention and improved drug management is also one of the most important applications, in which real-time data obtained from sensor enables physicians to administer drug and evaluate response in case of emergency. Such timely interventions offer high-tech medical assistance and reduce the cost of hospitalization. IoMT based RFID tags manage drug availability problems and supply cost. The FDA suggested guidelines for RFID and drug supply chain management. These include the addition of these tags on medication packaging, which enables manufacturer to ensure supply chain quality. There are other solutions that add to this technology for medicine, such as WEC Pharmatech and TrueTech Technologies have developed edible IoT smart pills which help monitor drug doses and patient pharmacodynamics. Such solutions may help drug companies mitigate risk and losses during supply chain and administration. There can be other application areas, and they require the training courses and coaching representation to paramedical staff, assistance in rehabilitation and hospitalization, access to health information, electronic health records without loss of medical information, online protein analysis, and accuracy of composition. Now let us see that in each of these application areas, what are the opportunities to save the cost. So in chronic disease monitoring, health disease such as heart disease, asthma, and diabetes, they are coming in this category. There is opportunity for an individual to save $200 billion, and for commercial opportunity to save 15 billion. Telehealth, which includes routine remote checkup and psychological care, $100 billion can be saved, and commercial opportunity to save $12 billion. In wellness and preventive care, such as obesity, smoking, cessation, lifestyle monitoring, the opportunity to save is indefinitely large, and commercial opportunity to save is around $6 billion. So you can see that by including these IoMT devices for monitoring and various other purposes, such as diagnosing, can cost a lot of save a lot of cost at the patient end, as well as it helps the healthcare industry to utilize their resources very efficiently. Now comes one of the most important aspects of this IoMT, and this is one of the most important concern also. So healthcare is and was a top target for criminals. If you talk of statistics, 72% of malicious traffic is targeted at healthcare providers, 40% year-on-year increase in healthcare cyber attacks, and 81% of healthcare providers have revealed one or more systems have been compromised. These attacks can be to alter the data or maybe to steal the data from the healthcare infrastructure. So there are some cases where IoMT vulnerabilities have been highlighted, like MRI devices have to assess patient information, and in this researcher was able to hack into hospital network with ease and permission after finding vulnerable medical devices. Infusion pump hacked to administer fatal drug dose. Security professionals showed how easy it is for hackers to take control of hospital drug infusion pump by overwriting the device firmware with malicious software. So theft of data as well as alteration of data is possible through these cyber attacks in IoT devices. Now, the reason of these IoT vulnerabilities is 7 to 8 years device development life cycle. Devices built for patient safety, not security. Use of outdated OS with known vulnerabilities. Limited or no patching capabilities. No support for third-party security agent. And limited regulatory focus on security and unencrypted communication is one of the reasons of one of the major reasons for these IoT vulnerabilities. So there have been reports of such breaching of data and infecting of medical devices with malware in various tech magazines across the world, where the attackers have succeeded in penetrating to hospital networks to steal confidential data of patients. So the greatest areas of vulnerabilities are emails, mobile devices, Internet of Things, other end user devices, and network. The information security tools are very less implemented, like network monitoring tools, mobile device management, intrusion detection systems, intrusion prevention systems, and data loss prevention systems are very less implemented in IoT infrastructure. So in an IoT security framework, first of all, the scope has to be determined, and then the gaps have to be identified and processes have to be updated. I'll move on a little faster with these slides. So in this, what is needed is to make an inventory of authorized and unauthorized devices. The type of inventory, usage, and location of each medical devices is to be determined. Determine the known vulnerability in each device type, and then OS patching and default settings may be applied. Score device risk based on type, use, location, and data transmitted. And based upon that, the implementation of security tools may be applied to those devices. Next is need of identifying gaps and updating the processes. In this, there has to be a collaboration between IT and biomedical so that security assessment can be added as a key criterion. Deployment and monitoring of IoT devices in healthcare should be continuously there, and its assessment based on risk has to be there also. And whenever there is a high risk device, then there should be a migration plan to replace such high risk devices. So these are some of the possible technologies and connection protocols which can be used to integrate various IoT devices with IT infrastructure to implement the IoT or biomedical device connection security. So visibility is one where real-time discovery and comprehensive profiling is to be done for every network. All the devices have to be authenticated on onboarding, and automatic onboarding should be enabled. Monitoring the identity, behavior, and location of device is necessary. And alerts, quarantine, and blocking of device should be enforced. So based upon certain signals, there are certain actions which have to be taken to ensure the device security. Nowadays, there is a trend of using artificial intelligence also to analyze the behavior of the IoT devices so that a breach can be detected whenever it is there. So in this, what is being monitored is the identity, location, and behavior to detect any network intrusion, MAC spoofing, rogue IP, rogue device, vulnerable device, and unauthorized access. So the main focus of IoT security is to integrate IoT and big data analytics and help find means to analyze incoming data as it is collected and transported to connected devices. For example, incoming data from monitoring a patient vitals in the hospitals can be effectively collected, sorted, and analyzed, stored, and made available in a format which is easier to use for further treatment purposes. Develop applications and device software for medical purposes which are enhanced and better version of existing ones. Offer platform as a service by developing high speed and highly efficient cloud computing platform where user can have IoT applications running seamlessly by linking to it. And at the same time, it is important that the security of these IoT devices is also taken well care. The perspective related to IoT and its security are that IoT and cognitive computing together can create intelligent networks which learn from incoming inputs and respond accordingly to the user. An IoT application which has a feedback system can give healthcare and fitness suggestions to the user based on data collected. This can also act as personal healthcare assistant which regulates and schedules clinical visits, give diet control alerts, and so on. Instead, opting for private networks, collaborate with the leaders in the IT service industry to create an open ecosystems with standardized API which enables interoperability with a reliable and automatic patching system. Devices must be well protected and tested before the final implementation, and making sure that it adheres to all necessary security protocols. Connect these devices to secure networks alone. A collaboration between device manufacturer, enterprises, and end users is necessary for this solution to take effect. So in this, what is suggested is that there should be a standardized API which is there in an open ecosystem, and it enables interoperability. Like there are some certain APIs which are open sourced, and these APIs, such similar kind of APIs also need to be developed in IoT environment so that there are no private networks, because whenever there are private networks, there is a possibility that that the security is not so well taken care of, and in this there is a need of collaborating with IT industry who are expert at security issues. So how to control and how to manage the security issues that can be there in IoT environment. So with this, I thank all of you for patient hearing, and if there are any questions, please ask them. Hello.
Yes, sir. Munish ji, thank you. Deepak Jamar here.
हाँ, thank you. जमर साहब कैसे हैं?
Hello. Thank you. A very excellent lecture. Useful lecture for
Yeah,
this.
actually, in this, some of our group members are also working, and they are doing it so that they are working in sensor development also, and they are also working in app development for healthcare systems, and we are trying to collaborate with the IT players such as Google for such healthcare apps. So, if there are any questions,
You have slightly diversified your field,
sorry,
current field.
sorry.
I think you have diversified your field, no?
Yes, yes, yes.
I think it is.
Yes,
Yes.
yes. Basically, my primary area of interest is photonics and optical communication. But
Yes,
since
yes, yes.
optical communication and photonics are the technologies, and application areas can be anywhere like IoTs, IOMTs, and
Yeah.
also in image processing and other areas. So now there is we are also exploring the applications of photonics and optical communication.
Yeah. You are entering in our field. Trespassing. Yeah. Okay, thank you, Manishji. Thanks.
Thank you very much.
Thank you, Manish sir, for accepting our invitation and sharing your valuable time and knowledge with us. And thank you all the participants for being with us. And in this, our next session will resume at 11:45 a.m. So be with us at 11:45. And thank you very much, Manish sir, for joining.
Thank you very much, Umesh sir, for
Thank
inviting
you,
me.
Manish sir. I'm Shamsundar Agrawal here. Thank you very much.
Thanks, Agrawal sir. Thanks for inviting me.
And
It's
thank
a
you to all
pleasure
the
to.
participants also. Thank you, Umesh sir, also for coordinating this session. And thank you all the participants for being here. Thank you, sir, Manish sir. Thank you very much.
Thank you, sir. Thank you.
Right. If anybody wants to ask something, expert is still there. So if anybody want to say something, may ask. Okay, sir. There's no queries. So thank you very much again.
Thanks a lot. Thanks for inviting me.
Thank you, sir. Hello, Mukesh sir, are you telling something?
Sir, when next, like next session will start, sir? When
Next
it will
session.
start?
Next session will start, as Umesh sir told, at 11:45.
Okay, sir. Okay. Thank you, sir.
हाँ श्याम सर कुछ कह रहे थे आप
हाँ मुकेश सर बस I just wanted to ask you how are you because you were saying something.
Yeah fine now my audio is clear.
Yes, it is audible, but not as clear as Umesh sir's voice was.
Okay, I again call Valvi ji.
No, it is comparatively very.
I think, Shyam sir, I think Mukesh sir have made arrangement that his voice should be ambiguous.
Okay.
Mukesh sir, I invite you here in computer center. You can coordinate the session from here directly.
Yes, sir.
Right.
Okay, it's Mukesh sir trying to coordinate the session.
Thank you all.
Thank you
Thank you very much.
Okay.